Practice quiz 8.1, 8.2. This is actually video number 2. On this one, we're specifically focusing in on solving exponential equations. The first video was too long. Anyway, let's jump right in. So we have an equation here, but our variables are in the exponent position. And the key to getting this to be a regular equation with variables not as exponents is to have the same base. If you have the same base, then you could just eliminate those bases and the exponents come down, and that's your new equation. So this looks like a really complicated equation, but it's really a simple algebra 1 equation, because the 36, they pretty much just disappear, and you have 2x minus 7 equals negative 5x plus 14, and it's just an algebra 1 problem. Let's get x by itself on one side. I'm going to get the 5x to the right side by adding 5x. I will have 7x minus 7 equals 14. Now that I have x on the left side, let's move all the numbers to the other side by doing the inverse operation. I want to get rid of the minus 7 by adding 7. What I do to one side, I do to the other. I will have 7x equals 21. Final step would be to divide by 7. Divide by 7. Final answer is x equals 3. You got to type that in with no spaces between your terms, and you will get full credit. So just like the previous question, we have an equation that has variables in the exponent. We don't want variables in the exponent. We want them to come down as a regular equation, regular variables, not variables that are exponents. So the key is to get the same base. Okay, so I have a 3 right here. This is an 81. The question is, could I change 81 to become that base 3? Okay, let me put some scratch paper here so I can show my work. So again, that 3, it has the 3x plus 6 up there. We have an equal sign, and the 81, I need to change that to become 3, okay? So if I'm not too sure about this, I could get a calculator and just go 3 to the second power, that's 9. 3 to the third power, that's 27. 3 to the fourth power, that would be 81. 3 to the fourth power is 81. So check with the calculator and figure out that 81 is really 3 to the fourth power. Now, all I did was replace 81 with 3 to the fourth. Now I still have the x minus 2 as a power right there. So what I really have is a power to a power, and we all should know with the rules of exponents, with the power to a power you multiply. So I need to multiply 4 times x, that'll give me 4x, and 4 times negative 2, that'll give me a negative 8. So here's my new equation. I have 3 to the 3x plus 6 power equals the base 3 to the 4x minus 8 power. Now that we have the same base on both sides of the equation, we could eliminate those bases, gone, gone, and we will have a simple regular algebra 1 equation. 3x plus 6 equals 4x minus 8. And now let's just get the x by itself on one side. I have x's on both sides of this equal sign, so let's get rid of one of them. I'm going to subtract 3x. Subtract 3x. That'll cancel. I will end up with 6 equals 1x minus 8. And for my final step, I need to get rid of that minus 8 by adding 8. By adding 8, I will get 14 equals x. X equals 14. That's what you need to type in with no spaces between your terms, and you will get full credit. As you can see, the correct answer is x equals minus 14. Okay, or you could just type in minus 14. Let's move on to the next question. Again, we need to solve, and again, we need the same base. So the only way I see an 8, I see a 16, but 8 to the second power, is that 16? No, 8 to the second power is 64. So I can't change these to base 8. So maybe I need to change both of them. So 8 could be changed to what? This 8 could be changed to what? 3 to the certain power? No. 2 to the certain power? Yeah, 2 to what power gives you 8? 2 to the third power gives you 8. And of course, you have the 3x minus 1 as a power on that 2 to the third power. Now, how about over here, this 16? Since I changed this one to a 2 to the third, let's see if I could change 16 to become 2 to a certain power. Okay, and of course, there's a big equal sign between those two. So 2 to what power gives you 16? 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So you really have 2 to the fourth. And of course, it's still to the power of 2x plus 3. And of course, with rules of exponents, when you have a power to a power or a power to a power, you need to multiply. So you have a number 3 times a binomial 3x minus 1. You will distribute. And remember, because you both have the same base 2, we're going to eliminate those bases of 2 after distributing. So 3 times 3x, that's 9x. 3 times negative 1, that's a negative 3. 4 times 2x, that's 8x. 4 times 3, that's 12. And of course, these did have the base 2 on them with an equal sign between them. But we said that we could eliminate those bases once they're identical. So we could eliminate this base 2 with that base 2. And technically, the exponents come down and become a regular equation. So now let's just solve this algebra 1 equation. We want to get x by itself on one side, so I'm going to move the 8 over to the left side. I'm going to eliminate it by subtracting 8x. Subtracting 8x. I will have a single x minus 3 equaling 12. Final step, plus 3, plus 3. I will get x equals 15. So my answer is x equals 15. As you can see down here, correct answer is x equals 15. No spaces between your terms. Alternative answer is to just type in 15. Either one will work. So we have an equation right here, and we have different bases. Step 1 is to make these bases the same. So first thing you're probably thinking is, maybe we could change 8 to become base 4. Like as in 4 to what power gives you 8? It doesn't work. So if that doesn't work, you got to change both bases, right? We're going to change that 4. We're going to make it a 2 squared, which is really a 4. It still has the power of negative x plus 5. Still has an equal sign. Now the 8, I'm going to change that to become 2 to the third. And we still have the power of 6x minus 10. So now that we have the same base, we'll be able to eliminate those bases, and the exponents will come down as your exponent, as your new equation. However, I do need to distribute power to a power. 2 times negative x is negative 2x. 2 times 5 is positive 10. 3 times 6x is 18x. 3 times negative 10 is negative 30. And of course, when you distribute power to a power, this is your new power over the base 2. So you have a big giant 2 right there. And again, this power to a power, that's the power over base 4, or on top of, base 2, not 4. And of course, this equal sign is now between those two red 2's. And of course, the whole purpose of getting the same base is to eliminate those bases. And then your exponents come down. Negative 2x plus 10 equals 18x minus 30. Now you solve this equation simply by adding 2x here, adding 2x over there, giving you a 20x minus 30 equals 10. And then we move the 30 by adding 30, adding 30. You're going to end up with 40 equals 20x. We're going to divide by 20, and we will get x equals 2. So that's your answer for this question. And as you could see, the answer is x equals 2, no spaces, or you could just type in a 2, and that's it. Let's move on. Man, I love these questions. Yeah, we have 1 over 16, we have 1 over 32. We want these to be the same base, and we don't want fractions either. Okay, so the 16, I want to change that 16 to become 2 to the 4th power. Okay, I know I could change 16 to become 2 to the 4th power. But again, I don't want 1 over 2 to the 4th power. I just want the base 2. So I am going to take this 2 to the 4th and move it up. and that will make it a 2 to the negative 4 inside those parentheses, but notice that I no longer have a fraction, okay? But I still do have the power of negative 2x plus 4. I still have the equal sign. I want to do the same thing to this side over here. 32, I'm going to rewrite it as 2 to a certain power, okay? So I'm thinking 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's really 2 to the 5th. And of course, you could use a calculator to figure that out, but 2 to the 5th is really 32. I'm going to take the 2 to the 5th and move it up to the top, and that will give me 2 to the negative 5, but no more fraction. And I still have the power of negative 2x minus 8. So negative 2x minus 8. At this point, I have a power to a power, right? A power to a power. This one's a number, this one's a binomial. I need to multiply power to a power. So when I multiply the negative 4 times the binomial, I'm going to have to distribute the multiplication of negative 4. So let's distribute negative 4 times negative 2x, that's positive 8x. And of course, this is going to be on the power of base 2. And then negative 4 times positive 4, that's negative 16. We do have an equal sign here. And let's distribute this power to the other power. Negative 5 times negative 2 is positive 10x. Negative 5 times negative 8 is positive 40. And of course, that is the power on the base 2. So what we have here is 2 to this power equals 2 to this power. Because we have the same base 2, we could eliminate those bases and have a simple equation. 8x minus 16 equals 10x plus 40. And let's continue to solve this thing. I want to move the x's. You see I have x's on both sides of my equation. I want to move the x to the left side by doing the opposite of 10x, which is a negative 10x. That will eliminate negative 10x. We will have a negative 2x minus 16 equals 40. And now, from there, I'm going to get rid of the 16 by adding 16, adding 16. I will have negative 2x equaling 56. And then we are going to divide by negative 2, divide by negative 2, giving us a final answer, x equals negative 28. So that would be the answer to this problem. Let's move on to the next question. All right, we have to solve this inequality. And of course, in order to solve exponential equations or inequalities, you want the same base, both on the 128 and the 32. You want the same base. So you don't want them to be different numbers. So, like if this were a 36, I would try to change this to a 6 squared and change that to a 6 to a certain power. But obviously, it's not a perfect square term, so I'm going to just jump right into the base 2, okay? And of course, you could use a calculator. Instead of 32, I want to rewrite this as 2 to a certain power. So with the calculator, you could say 2 to the 4th power, test it out. But I want to do it by hand right now. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I know that that is 2 to the 5th power. How about the 128? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So I did that counting with my fingers. I get 2 to the 7th is 128. And of course, we still have the powers of 2x minus 3 on the first one and the power of 4x plus 3 on the second one. And of course, a power to a power, you need to multiply, so distribute. 7 times 2x, that's 14x. 7 times negative 3, that's negative 21. And it is still an exponent of base 2. We still have this inequality, the less than symbol, the less than symbol. We have this 2 right here. But when you distribute 5 times 4x, that'll be a 20x on the exponent of base 2. And 5 times 3, that's 15. Okay, so now that we have the same base, we could eliminate those bases. My powers come down and my inequality comes down, and we have a new inequality to solve. So my new inequality is 14x minus 21 is less than 20x plus 15. So let's solve this thing by getting x's to one side. I'm going to subtract 20x, subtract 20x. That will give us a negative 6x minus 21 is less than 15. So at this point, I am going to get rid of the minus 21 by adding 21. Adding 21, that's going to give us the new inequality, negative 6x is less than 36. Final step, divide by negative 6, divide by negative 6. That eliminates x. Because we divided by a negative, this guy needs to flip. So it's going to flip to become a greater than negative 6. And there's my answer. X is greater than negative 6. Let's move on. On this question, it's asking us to find the range of this exponential decay function. I already know it's a decay because the growth factor of the base is less than 1. It's between 0 and 1, which is a decay function. From left to right, it's going to infinitely approach your asymptote. In this case, the k value of y equals 5. So just by knowing these things, the a, that it causes a reflection, vertical stretch, the exponential decay function, and the asymptote y equals 5, I should be able to determine what my range is. So let's do a quick sketch and let's walk through all the transformations. The original exponential decay function, y equals 1/2 to the x power. From left to right, it decays down towards the asymptote, okay, and it continues forever that way. But of course, this has a negative in front, so that's going to cause a reflection over the x-axis. So it's going to be down here like this instead. Okay, so it's going to be down here like that instead, okay? So we could technically delete the blue one. You know what? Yeah, let's delete it. Let's erase it. So we reflected it. What else? It gets vertically stretched by 4. So that would just mean that it gets a little bit more curved like this, but who cares? And it has the asymptote at 5, so it shifts 5 units up. So let me do that. We have a 1, 2, 3, 4, 5. So here's my asymptote at y equals 5. And this guy shifts up to be on that infinitely approaching that asymptote. So that red graph is going to look something like this. This is just a sketch. It's not perfect. But I do know that this new graph is below that asymptote value of 5. It never actually touches. So what is the range in terms of y's, in terms of up and down? Where's your graph at? Yes, it goes forever down, but it doesn't go forever up. It actually infinitely approaches that asymptote y value of 5. So this whole thing is below 5. So your range is y is below 5. This is your answer. And your range will always be y is either greater than your k or y is less than your k value. And in this case, your h is 0 because there was no number being added or subtracted to x, and your k is 5. So in this case, it's below 5, so y is less than 5. Now, if you blanked out, you could always go to Desmos and type the original equation in, and you'll see that it's below 5, and you should be able to conclude that your range is y is less than 5. Last question. They want us to find the y-intercept. And in Algebra 1, we learned how to find the y-intercept. Now, one option is to graph it on Desmos, and you could look at where it crosses the y-axis, but we should remember from Algebra 1, to find the y-intercept, you set x equal to 0 and solve. So we're going to set x equal to 0 and we're going to solve this thing. So I have a 2 times 1/5 to the power of, when I plug in a 0 right here, 0 minus 4 is negative 4. So I have a power of negative 4 right here, and then I have a minus 6 at the very end. So I need to do this math, and then I'll have my y value, because obviously this says y equals, right? So if I do this math, I'll be able to find out what my y value is. And of course, the y-intercept is a coordinate, and they want you to write it as a coordinate in coordinate format. So your x value of your coordinate obviously is 0, and the y value we are about to find out. The y value we're about to find out. So let's do this math to find out what y is. Whenever you have a negative exponent, You could distribute that negative exponent and then move your negative exponents to the other side and change them to positive, or you could flip this right from the beginning and then change that to a positive and distribute your positive 4s. So I'm going to, what am I going to do? I'm going to distribute the negative 4. Okay, so I have 2 times 1 over 5, but the 1 has a negative 4, and the 5 has a negative 4, and it still has a minus 6. But of course, the 1 to the negative 4s are going to go down, and the 5 to the negative 4s are going to go up. So what you really have is 2 times 5 to the positive 4 over 1 to the positive 4. And 1 times 1 times 1 times 1 is still 1, which means it's unnecessary. So what I really have is 2 times 5 to the 4th, because you don't have to put it over 1, especially 1 to the 4th, and then minus 6. So this is something that we're going to do with a calculator. 5 to the 4th power, 5 to the power of 4. I'm doing it right now with the calculator. I just hit equal. That is 625. So I have 2 times 625 minus 6. And with the calculator, I want to do that, 625 times 2. And that will be 1,250. And then take away 6, final answer is 1,244. So the y value equals 1,244. 1,244. So the y-intercept that you need to type in is 0, 1,244. That's how you're going to type it in. That's how it's done. So that is the answer to this question, finding the y-intercept. As you can see, there's the answer, 0, 1,244, in parentheses.